welcome to Let's Talk ASPM. And today we're going to talk about something which is really very relevant and very active in the industry right now, which is the recent NPM software supply chain breaches. And I say breaches plural because there's been a few of them, and it does seem to be exploding. And I'm joined by Rohan as a regular co-host. Rohan, why don't you jump in and tell us what's going on?
Yeah, open source security has been a hot topic, right? You use all these open source libraries and packages. Most of the focus is on vulnerabilities, code flaws in these libraries and packages, but more and more we are seeing the malicious nature of these incidents, these attacks, right? And this is what has been happening for last 2 to 3 weeks now, where popular open source packages, because obviously the blast radius will be much wider. Popular open source packages are being targeted by attackers. The targets typically start with the maintainers or publishers of those packages, and with the first NX package, the developer was targeted with a phishing attack. But I think there is a cascading impact of that, and the last week incidents where almost like 400 plus packages were impacted was an eye opener in some sense, because that's where the traditional tactic of essentially self propagation, what worms do, was used to essentially spread the malicious code to multiple open source packages. To the extent that within a matter of a couple of hours, I think there were more than 400 packages in their versions that were impacted. So the open source community came into spotlight, and the users of those open source packages were kind of sent to a panic and incident response and firefighting mode, obviously to kind of contain and mitigate those risks.
Yeah, and it's interesting, right? Because as you highlighted, it's not a traditional vulnerability management problem, right? It's not that, hey, there's an open source library out there, somebody's figured out a security flaw and we're exploiting that security flaw. That was kind of our log4j instance. This is a case of, no, somebody's actually compromised the contributor, the person responsible for that, and then something gets injected in, and the traditional CVE scanner approach just can't keep up. It can't move at the speed.
Yeah. It's mostly going to be reactive, right? Essentially, once you have been notified of that some incident has happened, then you have to react to it, and you have to react it then and there, right? Because uh, unlike CVEs, where hey, are we vulnerable or not? Is this exploitable or not? Reachability and test dependency, dev dependency, all of that doesn't matter here, right? The moment there is a malicious code, that malicious code is a big risk and or running on your workloads. And in this case, it's stealing secrets and further self-propagating, right? So it's spreading to different other packages also. So yeah, I mean, there is no room in this case. This is the world of incident response. This is the world of like EDRs of the world, except that EDRs have no visibility here.
Right. So we're seeing traditional approaches of phishing attacks, worms. Also, there was the incident a few weeks ago of leveraging like Claude Code as
Yeah.
as a cohort or an assistant in the attack, right, to expose secrets. Kind of like, what can somebody do to react because of how quickly this propagates? What are the measures that you can take to prepare yourself when you or respond to an event like this?
Yeah, and it goes back to the SolarWinds incident, right? Similar in nature. The supply chain was compromised, and the industry's response to SolarWinds breach was, "Hey, we want visibility. We want visibility in all the third-party code that we are using in our packages, in our applications, right?" And that's where the importance of software bill of material also came into picture. And this is a classic case where an organization where they would have full visibility into all the open source and third party packages that are being used in their applications and their products. They would have the visibility of like the name, versions. Those kind of organization would be in a much more kind of superior position, right? And ahead of the curve situation, where they could just go and look at, hey, do I have packages from these particular set of developers? Do I have the specific versions of these particular packages being used in my environment? Yes or no? If yes, let's go and jump into action and mitigate that risk. But if you don't have visibility, and which, again, like scanners may not have that visibility, may not give you that visibility because these packages may not have any vulnerability at all, right? So you need to have visibility, inventory of sorts of what all open source packages are being used, what all applications are using each of these open source packages in specific versions, and from there on, essentially, kind of do an incident response on that.
So kind of like your first line is to say, okay, what what libraries am I using? Am I using any of these vulnerable things? So I can get some of that data from findings, right? So if I've found a vulnerability in a library, I therefore have visibility that I have that library in place. But that doesn't give you a full inventory, because if it is an otherwise clean library and it doesn't have any vulnerabilities, you don't necessarily know, right? Tree falls in the woods and nobody's there to see it. Does the tree actually fall? So you mentioned software bill of materials, and I think most people are aware of that today. Executive order a few years ago, Cyber Resilience Act now in Europe, kind of like also driving on top of that. Talk a little bit more though around what an SBOM provides us, and how we can get access to them. Where do they fit in my software delivery pipeline, both the software that I'm developing, but maybe systems or components that I'm leveraging from third parties.
Right. Software bill of materials would essentially give you a specification, right? It's an ingredients list, right? Just like you would buy a package from grocery store and you would see the list of ingredients. That's what it is. It's a list of all the ingredients that have been used. Except for that, the software bill of material not only gives you the list of ingredients, but additional characteristics of those ingredients. For example, what's the package URL, right? What's the package manager? What's the checksum of that particular package? So all of that information makes it very easier to pinpoint to which particular open source package and which version of it and where is that hosted. All of that information is present in the software bill of material. Essentially making it much easier, because softwares are developed over time and you always want to know, okay, which point in time snapshot of an open source package is what I have. Generation of that is becoming very commoditized today, right? It's quite easy. If you are using GitHub, there is a way to get software bill of material out of it. If you are using any CI/CD pipeline, you can use a lot of open source tools. Some of them are kind of published by the software bill of material specification provider like CycloneDX and SPDX. So you can use those tools to generate a software bill of material as well. So it's and if you're using an 𝗙cie solution already, for most customers are, most organizations are, that should also be able to provide software bill of material very easily.
Okay, so I get that list of ingredients. So if I've got my own development team creating software within my organization, I can get data from the pipeline. I can get data from the software composition analysis tools like a SemGrep, for example, or a Snyk or a BlackDark. I can also leverage open source tools and frameworks. CycloneDX, you referenced, that's one format. SPDX is another format as well. And actually, it's not just about the software that we are building, though, as well as it's the software that we're using. So in a world like a product security world, where I'm embedding other people's systems and technology into the product that I'm ultimately delivering to market, I need those SBOMs from those third parties, because I'm probably not going to have access to their source code. I'm probably not going to have access to their SCA results, but an SBOM as a delivery will give me that list of ingredients so I can look at my composite environment. So once I have that, though, how does that help me? How do I then use that SBOM to be kind of a proactive or reactive, should I say, to an event like this?
Right. So, I mean, you can, in order to be reactive, right? Now that you have an inventory, you can kind of do a top-down approach on what packages are being used, what's the blast radius, and so on and so forth. The other aspect to this is you can also very much be more proactive to this approach, right? A lot of these packages are not actively maintained. The sources where you publish these packages, like NPM registry or GitHub, where the source code is, they would clearly mark these packages, specific versions, as deprecated, archived, end of life. So once you have the software bill of material and the open source package data, right, you can always go and enrich that with additional open source information that is frankly in the public domain. Right? You could also look at indicators of how secure the practices, how secure the practices that are being followed by the developers, right? So is their CI/CD pipeline secure? And in this case, right, no, ideally the NPM packages should only be should the developer should have the controls in place so that they could only publish the NPM packages through their GitHub Actions, through their CI/CD pipeline, not just by uploading a file, right? So all these kind of controls can also be evaluated by a lot of open source standard. OpenSSF scorecard is one of them, where it essentially has a checklist of things that would evaluate all the open source packages against and give you a score of 0 to 10, 10 being that this is like following the most secure and ideal practices around maintaining and building the particular package. So the software bill of material information, once you have that consolidated in an inventory, right? Yes, it helps you in a reactive manner, but you are in a position to be more proactive also. Hey, let's take a campaign to remove all the deprecated stuff. Let's also start looking at all the open source packages where not deprecated, but scorecard is less than 5. Can we find alternates for our teams for that, and then help them kind of switch their packages to a different package? So
Yeah.
yeah, I mean, without visibility, none of that would be possible, right? Step one is visibility, but then there is enough intelligence and information available in the public domain to be leveraged.
Yeah, so taking that data, that in quality intelligence, how well it's being maintained, what the development practices look like, as well as threat intelligence information to say, hey, proactively, we know that this library has got an increased amount of threat actors working within it. As you and I both have done, we've spoken to threat intelligence providers before where they'll talk about, hey, we knew about Log4j 2 weeks before it became a CVE. Would have been great if, as a community, we could have reacted to that, right? So, and that's really, of course, where our software supply chain module, ArmorCode, comes in, right? Not only aggregating the finding data to that inventory, but giving you that metadata around the quality and the threat intelligence, bringing that all together into one central place. As you think about the direction, though, that this ultimately goes, how can we look to the future, right? Because this isn't going to be the first time, right? We've identified a way as to how we can react better with findings and software bill of materials, how we can be proactive with leveraging threat intelligence or quality OpenSSF orientated data. What does the future look like? How can we even move towards autonomous, or dare I say agentic workflows from an AI perspective?
Yeah, there are a couple of answers to it right now. One is you already have a lot of data points available. Is it just can it just be that when the next incident comes in, right? An agentic AI platform would automatically identify that there is a new NPM breach, or for that matter, right? Let's take the example of the current breach, and it's still supposedly an ongoing situation. There are 50 more packages that gets added to that list. Can there be a platform where it would go on and identify there are additional 40 packages, added to your list of all your incident response, the actions that you have taken, create additional tickets, and work in a more natural language manner where, as a security manager, right, or as a CISO, I would be able to go on and talk to the platform and just ask, hey, am I vulnerable, right? Which is literally the question that executives want to get answers to, right? But to get a real thumbs up, thumbs down answer to that question, it takes hours and in some cases days, right? But agentic AI has the ability to essentially, number one, like get access to the right data, and then number two, orchestrate the overall workflow to kind of give us answer in a matter of few minutes, because it can look at the data, it can look at the impact, it can look at also the threat intel sources to see, okay, what's going on, what's the latest in this particular incident. And that's where the future is. The answer to basically the question of, am I vulnerable? How big is this for us? Should be coming out in a matter of minutes instead of hours and days.
Yeah, and certainly that's the focus of really how we can leverage AI as an industry, not only as ArmorCode and how we've introduced things with Anya, our agentic interface, but as an industry, how can we leverage AI in a way to improve our productivity, respond faster, because the bad guys are already using it. I mean, the example of, in essence, using Claude Code as an assistant in an attack, is a good example of how the threat actors are getting creative. We also need to be creative as an industry, and it's bringing all of that data together so we can expose those interfaces and workflows.
Yeah.
So I think this is going to be something to watch. Certainly this won't be the last time we're talking about a software supply chain attack. But I think it is a problem that can be solved. It is a problem that organizations are able to address it today. And I hope this was useful for everybody watching. Rohan, anything else you'd like to add before we wrap up?
Prediction time.
No, there you
I
go.
think there will be a ransomware attack that will hook up that will be hooked on open source packages and related issues in next 6 months.
Yeah. It's interesting how this has evolved from being a vulnerability orientation to really kind of a malware virus type of orientation, right? So yeah, it is. I think that's a pretty hard prediction. I'll look forward to doing that when we do our end of year wrap up show as well. We'll see if it's happened between here and there. If not, I think that's going to be a normal prediction for next year.
Not during the holidays, hope so.
Let's hope not. All right. Well, thanks everybody for watching. As always, click like, subscribe. Rohan, thanks for sharing the time with us today. And we'll look forward to seeing you all on the next podcast.